All right, hey everyone. If you're a grade 10 math teacher, you know the deal. You get to the geometry unit, and suddenly it's all about circles. And getting those circle properties to really click for students, well, that can be a real challenge. So today, we're going to talk about how to turn that struggle into a genuine aha moment.
I mean, we've all been there, right? You ask this question and you already know the answer. You see students just cramming these theorems, hoping to remember them long enough for the test. They're learning the what, but they have no idea about the why. So let's talk about how we can finally bridge that gap.
So here's our game plan for today. First, we'll nail down the real challenge with circles. Then, we'll talk about a small shift in our thinking that makes a huge difference. After that, we'll walk through 3 super practical problems you can use tomorrow. Then, we'll get into a great collaborative activity, and we'll wrap up with the big classroom takeaway.
Okay, first things first, let's really get to the heart of why circles can be so tough and why our students default to just memorizing a bunch of rules. You know, when a student just memorizes a rule, like the angle at the center is double the angle at the circumference, that knowledge is, well, it's brittle, it's fragile. The second you give them a problem that looks a little different, the whole thing just shatters. Real, lasting understanding comes from seeing the connections, the logic behind it all. So, if memorization isn't the answer, what is? How do we help them build a stronger foundation? Well, the key is making a shift in our approach, a move towards what we call higher order thinking. And listen, HOT isn't just some fancy buzzword we throw around in staff meetings. It's an action. It's about getting our students to actually do things with the information they have, to analyze it, to justify their thinking, and to apply what they know to problems they haven't seen before.
We can actually give them a simple 3-step playbook for every single problem. First, analyze. What pieces of the puzzle do I already have? Second, connect. Which rule or property fits here, and more importantly, why? And third, justify. How can I explain and prove that my answer is correct? Okay, theory is one thing, right? But let's get our hands dirty. Let's see what this actually looks like in the classroom with 3 classic circle problems. We'll kick things off with a real cornerstone of circle properties. This one comes up all the time. All right, let's sketch this out together in our minds. Picture a circle. Pop a dot right in the middle for the center. We'll call it O. Now let's place 3 points, A, B, and C, anywhere on the edge. If we draw a line from A to O and from O to C, we form an angle at the center. Let's say that's 130 degrees. The question is, what's the angle way out at point B? And here is that little bit of magic. Instead of just telling them the rule, we ask this question. We're not giving them the answer, we're prompting them to find the connection themselves. We're guiding them to see that both angles are related to that same arc, AC. And bam! As soon as they make that connection, the light bulb goes on. The property itself does all the heavy lifting for them. They realize the angle at the circumference has to be half the angle at the center. So 130 divided by 2, it's 65 degrees. The thinking is in the connection, not just the calculation. All right, ready for another one? This time we're going to move from angles inside the circle to a line that just, kisses the very edge of it. Let's talk tangents. Okay, picture it again. There's our circle with its center, O. Now imagine a straight line that perfectly skims the outside, touching it at just one single point. We'll call that point P. Now draw a line from the center, O, out to that exact point P. The question is simple. What is the angle right where that radius meets the tangent? You're seeing the pattern now, right? It's another guiding question. We're asking them to think about what is always true in this specific situation. What's that special, non-negotiable relationship between these 2 lines? And this is one of those beautiful, concrete rules in math. It isn't sometimes 90 degrees, it is always 90 degrees. A perfect right angle. Every single time. The property is the proof, and the answer just falls right out. Okay, one last example to really lock this in. And honestly, this one is my favorite because when students see it for the first time, it kind of feels like a magic trick. All right, last time, let's sketch it. We've got our circle. This time, throw 4 points on the edge, A, B, C, and D. Now draw a straight line from A to B. That's our chord. See how that chord forms an angle way over at point C? Let's say we know that angle is 40 degrees. Our mission is to find the angle at point D, which, if you notice, is formed from that exact same chord, AB.
So here's our final prompt. We get them to notice that both angle C and angle D are standing on the same foundation, that arc AB. So what does that tell us about them? What can we say for sure?
And the property is just so clean and elegant, they have to be equal. It doesn't matter where C and D are, as long as they're in that same segment. So if angle ACB is 40 degrees, well, angle ADB has got to be 40 degrees too. No calculation needed, just a beautiful, simple application of the property.
Okay, so we've modeled the thinking, we've guided them through the process. Now it's time for the most important part. We hand over the keys and let them drive.
And here is a fantastic way to do that. Think of it like a Where's Waldo, but for geometry. Give them a really complex, messy diagram with circles and lines all over the place. Their mission isn't to find one right answer. It's to go on a scavenger hunt and identify as many different circle properties in action as they can. They become the detectives, and then, by presenting their findings, they teach each other. It's awesome.
So let's bring it all home. After all of this, what's the one big idea that I really hope you'll take back to your classroom?
This is everything. The moment we shift our questioning from, so what's the answer, to, okay, how do you know that? We're changing the game. We're not just building kids who can do calculations, we're building resilient, flexible problem solvers. And that transforms geometry from a list of rules they have to memorize into a fascinating, logical world they get to explore. And that is a lesson that will stick with them for a very, very long time.